We're going to talk today about solving equations with logs. So all of our examples will have logs and equal signs, and they are equations that involve logarithms. Now there are three types of situations. This first type up here is when you have a logarithm on both sides of the equation. So log of something equals log of something. Another type of situation that you'll see is when you have a log just on one side. And the third thing that we'll see is when you have two logs on the same side. They will each require very different strategies, so I wanted you to just be aware of the three and make sure that when you start a problem, you identify which of the three situations you have. So when it's log on both sides, we can use the same base strategy in the same way as the same log strategy. This one has a log base 10 on both sides. So because it's on both sides, you can cancel it out, and it is just what's left. 2x minus 1 on the left equals 13 on the right. And then we'll solve like normal. We'll add 1 to both sides and divide by 2. All right, when there's a log on one side, you cannot just cross out the log because you don't like it. It's not how it works. What we'll have to do to get rid of the log is switch into exponential form, and that will get us rid of the log. You can't do exponential form when you have a coefficient, so the first thing that we'll do is take and raise that to the second power with the power property. So now we have log base 5 of 3x squared equals 4. Now we can go ahead and do the loop and switch to exponential form. So 5 to the 4 equals 3x squared. I can distribute the 3, so it'd be 9x squared. Now I can solve for x. I need to figure out what 5 to the 4th is, so I'm going to grab a calculator. So 5 to the 4th is 625, and it equals 9x squared. I will divide by 9 and square root. So I end up with 8.33 and negative 8.33. What I want to make sure that I do with these is check for extraneous solutions. And extraneous solutions are when you plug in your x back into the original equation, you can only take logs of positive numbers. If it's a negative number, it's undefined. So if I plug in 8.33 here, I would get log of about 24. That's okay. If I plug in negative 8.33, I would get log of negative 24, and that's not okay. So in this case, I would only have one answer of 8.33. Next, I have equation with log on two sides. Or I'm sorry, two logs on one side. You cannot just cancel out the logs. It doesn't make sense. Here it makes sense because it's the same on both sides. Here you would just be taking them out without a mathematical reason why. So what I want to do with this is I'd like to get it into this form with just one log. So I need to take these two logs and combine them into one log. And I'm going to do that using the product property because they're separated by a plus. So log of this times this because they're separated by a plus. That gets my two logs into one log. Now I can go into this procedure where I switch from log form to exponential form. So there is no base, so I'm going to put in my invisible 10 that was there. Now it's a visible 10. 10 to the 2 equals all that. And now I'm going to solve it. I'm going to solve by first distributing my 5x, so it'd be 5x squared minus 5x. 10 squared is 100. And I now ended up with a quadratic equation. So I'm going to get everything to one side. And I'm going to first factor out the greatest common factor. Each of these has a 5 in it. So I'm going to factor out a 5. And now I just have to factor this. It would be x and x, because it's x squared, and 20 would be 4 and 5. Minus x would mean a minus 5 and a plus 4. All my factors I set equal to 0 and solve. This factor leads me nowhere because 5 doesn't equal 0. This one would lead me to negative 4, and this one would lead me to positive 5. I'll check for extraneous solutions again by plugging the negative 4 in. That would make that log of negative 20. You can't take a log of a negative number, so that is extraneous. 5, log of 25 would be okay, and log of 4 would be okay. Again, I'm just checking to make sure that I can take the log of the number that it's positive and that it didn't lead to the log of a negative number.